Hello everybody, my name is Mike Geig, and in this video we're going to be looking at using polymorphism in C#. Now, if you've never heard the word polymorphism, you might be thinking to yourself, what the heck is that? All right, it is kind of a weird word, and what I like to joke around that it's the spelling checker killer, because every time I type it, my spelling checker just goes nuts. Um, Basically, polymorphism is the ability for our base classes to pretend to be our inherited classes. All right, it works because we have this is a relationship. Kind of hypothetically, if I had a class called mammal, all right, and it described everything that was a mammal, things all mammals have in common, ages, genders, weight, height, just things mammals all have in common, all right? And then I were to create, like, say, class dog and class cow and class whatever, okay? They would all inherit from mammal, but a dog is a mammal and a kangaroo is a mammal. So I could have collections of dogs and collections of cows and collections of whatever, whales or mammals, I suppose. And I could have all these separate collections, or I could just have one collection of mammals. And using something called late binding, which we'll talk about a little later, we can get our mammals to act like dogs and cows and whales and whatever, without us really having to know which one they are. All right, so it's a special way for us to make this work. All right, so what we see here on the screen is just the code from our inheritance example. So my program has nothing in it right now. Here's my employee class. This will look very familiar. My salary employee class, again, nothing's changed. And my hourly employee class, again, nothing's changed. Okay, so we have calculate pay here in my hourly employee, and we have calculate pay here in my salary employee. Now, wouldn't it be nice if we could figure out a way of containing all of our hourly employees and all of our salary employees in one single list? Okay, and by list I mean an array or some other collection. All right, because right now I would have to store all of my hourly employees in one place, right? Because arrays can only have one data type. All right, and I'd have to store all of my salaried employees in a completely separate place, because again, arrays can only have one data type. So what I'm proposing is that we create a list of employees, not salary employees versus hourly employees, just a list of employees, and we can put both hourly employees and salary employees inside of it. All right, and that's something we can do. That's not polymorphism. I'll show you what polymorphism is. All right, so instead of creating an hourly employee array and a salary employee array, I'm just going to create an array of employees. All right, and I'm going to call it my emp list. And to create an array, we're going to do, oops, just like that. Now that is an array of 2 elements. Okay, now the first element and the second element haven't been initialized. The constructors haven't been called. They're simply placeholders at this point. They're placeholders for something. If I did like my emp list 0 dot toString, I might crash my program. I don't know if this will run or not. It might run. No, yeah, see, it crashes the program because object reference is not set to an instance of an object. So it recognizes that it is an employee, but no constructors haven't been run. That memory address that it points to is vacant. All right, so we need to create it. Now, normally we would have to do something like my emp list sub-0 equals new employee, right? If we were filling it with an employee. In this case, though, we're not. I'm going to say my emp list sub-0 equals new salaried employee. Okay, and I'll put in Mike, and I will put in age, and I will put in salary. Sure, why not? And the reason this works is because a salaried employee is an employee. So I can put a salaried employee inside of an employee object. All right. Now what won't work? All right. Well, here I'll show you. We can do my emp list sub-0 dot. Look at this. I can see the age, I can see the name, and I can see the toString. All of the things that are in this employee class. Well, where's my calculate pay? All right. Where is this? Well, it doesn't exist in here because employees don't have calculate pay, so we can't use it yet, and I'll show you that here in a second. So what I'm going to do now is my employee list sub 1 is going to equal a new hourly employee. So now I've successfully put salaried and hourly employees in the same list. Okay, let's say he makes $10 an hour and he works 42 hours, so we'll know his pay should be $420. So that makes it really simple. Okay. All right, great. So this is all well and good. We have successfully put salaried employees inside of employee objects. All right, that's easy enough. All right, so now what we want to do is we want to add our employee functionality, or salaried employee functionality, or hourly employee functionality into this example. So what I'm going to do in my employee list, I'm going to go ahead and add public double calculate pay. Now, since we don't know what kind of employee this is, we're just going to set this to return 0. Base employees calculate pay is going to return 0 because this should be remade inside calculate pay, or I'm sorry, inside salary employee and inside hourly employee. That'll be overridden. Now when we look at this, if I do my emp list sub 0 dot, I see a calculate pay. All right, awesome, fantastic. Okay, now we're not going to be able to use it in this context, so let's go ahead and do console.writeLine, and we'll do my emp list sub 0 dot calculate pay, and console.writeLine my emp list sub 1 dot calculate pay. All right, so this should work. Let's go ahead and run it and see what happens. Now you'll see here I get the zeros. Well, you might be thinking to yourself, hey, this is a salaried employee and this is an hourly employee. So my hourly employee should have this here. You can see it's already kind of figuring this out because it's green here, and I'll talk about that in a second. And it should be doing this here. And when I mouse over to actually see, hides the inherited member, right? So my base class is hiding, my inherited class is hiding a member of my base class using the new keyword if hiding was intended. Well, we're not intentionally trying to hide, we're actually trying to override. Okay, and so what's happening is, though, even though this is a salaried employee and this is an hourly employee, the program is still seeing it as an employee, and it's going to run the employees calculate pay method, all right, which is just basically a shell method. We don't actually want this to ever be called. All right, it just exists to enable polymorphism. All right, so what I want to do is I want to go ahead for my public double calculate pay. I want to use the keyword override. All right, and for my employee, I want to use the keyword virtual. Now what this is saying is this: my employee base class has a virtual function calculate pay, which means it can still be called, it'll still return 0 and all that. However, if a child class should want to override it, it can. All right, this is a security feature. Okay, virtual exists in the base class so that we give future developers, say a developer were to inherit from our class, we're giving them permission to override this method. If I don't want future developers to override calculate pay in my base class, I remove the virtual, and then they can't. Okay, so by putting virtual there, I am allowing this to happen. I'm saying, hey, future classes, any classes that inherit from this class, you may override this class. That's what the virtual keyword is saying. Now the override keyword is saying, hey, okay, I'm allowed to override it, so I'm going to override it, and I'm going to use this one instead. Okay, and I can do that here for my hourly as well, just like that. And now I'll come back here so we can see what's happening, and I'll run it again, and now we can see my pay is calculated. Okay, this long string for my salary and $420 for my hourly. Okay, so now it's working. All right, so the question is now, why is it working? All right, because we just talked about this is still an employee. All right, these objects here are still employees. All right, they're not salaried employees, they're not hourly employees, they are employees. Well, this is what's called late binding or dynamic binding. You can call it either one, doesn't really matter. All right, so late binding and dynamic binding is saying this. All right, the compiler, when it builds your program, is looking at this and saying, hey, this is a virtual function. So we're going to decide at runtime which definition will go with this declaration. All right, we're not gonna decide this right now. We're not gonna bind them together right now. We're going to late bind them or dynamically bind them. All right, and so at runtime, the program is going to say, yes, it is technically an employee, but it does point to a salaried employee object. So let's see here. Yep, we're allowed to late bind this, and yep, this one overrides it. So let's use this one. Okay, and so that's kind of the steps the program is taking to determine which one to use. All right, that's our late binding versus our normal binding process. And now let's say I don't want every class to override that. Let's say hourly employee is not going to override that. If I get rid of hourly employee, the override from the calculate pay of the hourly employee, and I rerun it, now we can see, hey, I didn't have to. All right, we could still run the calculate pay of the base class. However, in this instance, we don't really want to. All right. Okay. So I'll put override back. Now it's worth noting. Oops, that's not right. It's worth noting that while they're in this array, they are considered employees, not salaried employees or hourly employees. All right. In order to use them like a salaried employee or an hourly employee, we actually have to cast it back into its original form. And I can do that. I'm just going to show you this here. This isn't really part of polymorphism, but I'm going to show you anyway. So I can say salaried employee, my sal employee equals my emp list sub 0. Okay, and right now this is not okay because it's going to say, hey, it can't turn a salaried employee or an employee into a salaried employee. Saying an explicit conversion exists. Are you missing a cast? And we are. I'm going to say, where's that? I'll put a space in there so the IntelliSense will finish it for me. I can just say this, and now, hey, it's saying, hey, turn my employee list sub 0 into a salary employee and store it here. And then my sal employee will contain everything the my employee list sub 0 has. It just uses the appropriate ones. And so I can do console.writeLine. Let's do my sal employee dot toString just to prove to you that the contents of this object here appear in here. So we're going to see Mike 25 and whatever. And when I run it, I see my name is Mike. My age is 25. Also, I make $43,000 a year. Okay, so there you go. So remember that while we're putting things in a generic container, in this case the container of the base class, all right, we lose some functionality until we turn it back into what it's supposed to be. All right, this is nice in Windows programming because everything will inherit from Windows form library, right? And so if we create, I believe all the forms come from Windows Form Control. I'll have to look that up. I don't remember off the top of my head. Anyway, we can create a very generic list and put buttons and labels and text boxes and all this stuff in it, and then just use them all generically and cast them to what we need at runtime if we need to. Okay, so those are some cool things that we can do. All right, so I'm going to summarize here because we covered a really huge, powerful concept, actually really quickly here. So I'm going to sort of re-describe it. Okay, so basically what we're saying with polymorphism is that we are going to treat all of our objects, all of our salary employees, hourly employees, maybe contract employees or whatever, we're going to treat them as generic employees. We're going to be able to put them all into one generic container. All right, and then because this generic container has a stub function, because it's not really doing anything, it's a stub function, all right, that has the same name as shared functionality in all the children classes. So in our case, calculate pay. This has a stub calculate pay, and these have actual working calculate pays. And because our base class is virtual, the function in the base class is virtual calculate pay, and our child classes override that, we are allowed to use a method of the child class in the base class. All right, and that's not the normal. If you think about it, normally we can use all the methods of a base class in our children class, right? Because they inherited those. But we're going the other direction. We are allowing, all right, the base classes to use children class methods, right? Which, if you think about it, is really, really neat. Okay. Uh, the way I always like to describe it, say I can juggle, but my dad can't. All right, using polymorphism, my dad gains abilities that he does not have. All right, my employee gains functions that it itself does not have. All right, through polymorphism, we're going in the opposite direction of inheritance. Okay, and that's very, very powerful, especially in video games. If any of you are interested in video games, it's just monumentally powerful because we can give every one of our objects, enemies, bullets, ships, whatever, update and render functions, and then just create one collection of objects, right? And it just causes them all to update and render without ever knowing which type they are. All right, so it's a very powerful, what do I want to say, feature of modern programming languages. So be sure to understand it. If you missed any of it, go back through and rewatch this video. Maybe play around with some of your own examples or look it up online. It's definitely worth knowing. It's a very powerful tool. Okay, so that's going to conclude this video on polymorphism.